Hello and welcome. In this lecture, we're going to be learning about a strange phenomenon called an out parameter. This is a parameter that instead of passing the value in C++, we tend to pass the value out of a function. And we're also going to see about something called a constant reference and how these two concepts are kind of intertwined with one another. Let's dive in and figure this out. Now, the real place that references shine is in parameters to functions, because every time we create a float delta time like this in our tick component, what we're doing is we are taking a copy of that original float and we are passing it in to the function. So instead of doing that, what we might want to do is take a reference to it and pass that in instead. So let's imagine that we were to create a function in grabber.h called print damage. And as a argument to this function, we want to pass in a float damage. Now this, as I said, is going to make a copy of whatever we pass in and copy it into that variable created, this parameter variable, inside the print damage function. And we do need to have a return value of void here as well to complete it and a semicolon at the end. Let's go over into the C++ and continue this conversation. Let's create the print damage in here. Let's put the uGrabber class in front of it, and let's put some braces instead of the semicolon. So we've got a copy into the damage parameter variable, and it's safe because if I were to do damage equals 5, I'm only changing this variable here within print damage. I've got a copy of it, it's my own. I can't mess it up by accident. Now, what if I didn't want to make a copy? My alternative would be to take a reference. So what I can do here is I can put a float reference going into print damage, and I need to update that over in the C++ file as well. And then I might have this log message that we're using the reference for. Let's go and take this down and put that into print damage. So now we take our damage and we're printing it out. Let's update the log statement to say damage is this. Okay, so damage is this damage. And in our tick component, what we can do is we can do print damage and pass in our damage variable and put a semicolon at the end, and we can get rid of our damage reference for now, because what we've got going on now is a damage float. It's created in tick. The memory for this has been created here in tick. And then we go and give it to this print damage function. But because the parameter is a reference, we aren't actually copying this damage. We are taking its address and storing that in the reference instead, so that when we use this reference down the line, we're actually accessing the original piece of memory. So no copy has had to happen for this to print the damage. Now let's just check that this is actually doing what we would expect it to do. If I change the damage value to 5, for example, and then recompile and hit play, then go and have a look at our output log, indeed it's printing that the damage is 5. But because we've got a reference, we know that we can update that value. So what I can do is I could say within this function, I could do, hey, damage should be equal to 2, like so. And if I wasn't careful, if I thought I had my own copy, I might think that's okay. But actually, in the tick component, what we've done is we've changed the original variable. So if I put a ulog in here to inspect that original damage variable, and we put a %f and pass in the damage here. Let's live coding compile that, and we're going to hit play, have a look at our output log, and you can see that now the damage and the original damage have both been modified. They've both been changed to the number 2, which isn't great. You know, you could accidentally do a lot of damage, if you'll excuse the pun, by changing the variables that you weren't expecting to change. And here comes another use of that const keyword that we've seen in the past. If I stick const in front of my float reference, then what I'm saying here is that this should be a reference that you cannot change. You cannot call any non-const functions on it. You can't set it. You can't in any way change the contents of this variable. You can only use it. You can only read it. You can only see what is in there. So if we go back into our grabber CPP, we need to make sure that we put const here in the parameters as well. And we can go ahead and compile, and you see we get a build failure. And the error is saying that damage cannot be assigned to because it's a const variable. So that gives us the protection we need. So generally speaking, if we are trying to pass a variable in an efficient way where we don't want to take a copy, then we will always use the const keyword as well as using a reference, because this prevents us from accidentally changing that contents. Now, however, sometimes you do want to use it to change that value. And what we might have as an example, we might have a Boolean return value, and we might want to say has damage, but we might also, as we've done in Blueprint in the past, want to have a second return value. So we might say, have we got any damage? And what is that damage? Well, in this case, it actually makes sense to use a simple non-const reference, a float reference to the damage. And typically we would actually call this out damage, just to make it really visible that this is what's known as an out parameter. It's not a parameter for passing things in, it's a parameter for passing things out. Now, it can be a little bit of a weird quirk of C++, and it can be hard to spot. But generally speaking, if you see any parameters that are a reference but aren't marked as const, then you can pretty much assume that somebody intended to use that as an out parameter. So that's what we've got here. We've got has damage, and if we were to go and implement this over in the CPP, then we can put the uGrabber class in front here, and we can put braces, parentheses here. We're going to comment out the line in print damage what it's not happy about, because we're trying to set a const reference. And essentially what we could do in here is we could do some code, we could see if we've got some damage, and then we would print out, yes, okay, out damage equals 5, so that's the damage that's been done. And we're going to return true because we've got some damage that's been done. And this we can now use in somewhere like tick component to get hold of the damage. So here, instead of setting the damage 5, we might get the damage and print it if there is some damage. So we can say something along these lines: if has damage, and then we pass in the variable that we want to be populated with the damage. So damage, for example, and then we can have the body of our if statement, and we could only call print damage, for example, if there is any damage to be displayed, and we can remove this ulog entirely. So this is the way that we use non-const references as out parameters, a way of getting multiple return values out of a function. And typically when we do this, when we are calling to this function, we will create the variable, but we won't give it an initial value. So on line 39, basically I've got a float damage defined. I pass it in straight away in the next line. And this is another telltale sign that you are using an out parameter. I haven't given it any value right before I've passed it into a function, means that I'm expecting that function to put the value in for me. So this can be hard to spot at first, and it can be a little bit confusing, but these are the two rules that I would like you to remember. If you see a variable declared and not given a value and instantly passed into a function, ask yourself whether that's an out parameter. And the other rule is if you see a reference as a parameter, but it isn't const, then that might also be a hint that this is an out parameter. And of course, if the variable or parameter is named out something, then that's a dead giveaway that this thing is meant to be an out parameter. Great stuff. I think that's set us up very nicely for being able to do a sweep. So I'll see you in the next lecture.